Hello everyone, welcome to the YouTube channel Mission at Physics Exam. And guys, in today's video we are going to consider most of the important topics of atomic and molecular physics. And before this video I have already uploaded one video of atomic and molecular physics in accomplishment series. You can check it on the channel and you can check the accomplishment series playlist too to watch all those important videos. Also guys, in this video we are going to consider rest of the important topics, and with the help of all these videos which we are having in accomplishment series, you will be able to cover up many important topics of almost all the subjects, okay, in very less time. So yeah, even if you want to do revision, you can check out these videos. If you want to prepare the topics, you can check out these videos. So in very less time, get to know about many important topics, and all these are the topics from where there are great chances that you can expect the questions in your upcoming exam. Okay, whether CSIR net physics exam or gate physics exam or any other physics PhD entrance exam, in all these exams preparation, these videos will help you. Now let's quickly start the discussion. But guys, if you are new on this channel, that is Mission at Physics Exam, so guys, you can even subscribe this channel by clicking on subscribe button below this video. Also, after clicking on subscribe, you will get a bell icon there. You can click on that to get the notifications for upcoming videos which I will upload on this channel, that is Mission at Physics Exam. Now let's quickly start the discussion about all the important points I am going to discuss in this video, and each and every point will be very important, so don't even miss a single point from this discussion. Okay, and if you have not watched the previous video of atomic and molecular physics, you can even check that out after watching this video. Okay, now let's start the discussion. So guys, if we are going to talk about the topic we are going to consider in this video, the first topic basically, because after this there will be many other topics as well. So the first topic is vibrational rotational spectra. Clear? Now from this particular topic, what are the points you need to know? First thing, in which region you can observe it. So you can observe it in the near infrared region. Okay, that type of question you can expect. They can give you the different region in options, and they can ask you that in which region you can observe the vibrational rotational spectra. Second type of question you can consider or can be there in your upcoming exam, that can be related to what type of molecules will show the rotational the vibrational rotational spectra basically. So the answer will be heteronuclear molecules, because the homonuclear molecules will not show the vibrational rotational spectra. Okay, now next point, if we are going to talk about the next one, that's gonna be, and this is mainly the vibrational spectra topic which is going on right now, and before this we have already considered the pure rotational spectra. So rotational and vibrational, this one you will consider as vibrational spectra. Then where we will consider the vibration and rotation together, that topic will be after this topic we will have. Okay, so we will even discuss the that one, but if you are getting any question based on vibrational spectra, then you will consider these points. Okay, next point, if we are going to talk about the molecule, okay, as a harmonic oscillator, if you are considering any molecule, then what type of questions you can expect, and this topic is a part of vibrational spectra itself. Okay, so in this case guys, what is going to happen? First thing, you should know about the energy expression in this case. What is energy expression? That is h nu oscillations. Okay, V plus half. Now what are the symbols we have used here? They are representing what basically is the meaning of the symbol. Clear? So here nu oscillation or V oscillation, whatever symbol you are writing for this one, either nu or V, but in the suffix it's OSC written here, so it will help you to differentiate between both. Clear? So nu oscillation is the classical frequency of oscillator. Clear? And its value will be 1/2 pi root k upon mu. Now what is k here? That is force constant, and what is mu here? That's gonna be the reduced mass of the oscillator. Clear? And from this energy expression or related to the energy expression, you can expect the question, so it should be clear to all of you. Now the point is, what was this V within the bracket? That is vibrational quantum number, and its values will start from 0. It is a very important point that its values will start from 0, and it can have any value like 0, 1, 2 and so on to. Next point, if you want to write this energy expression in terms of wave number, in the last class or in the last session or the video which I have uploaded in this accomplishment series for atomic and molecular physics, I have even told you one thing, that anytime if you want to get or find the energy in terms of wave number, you just need to divide this energy expression which we have already observed by hc. Okay, so when you are dividing it by hc, you are getting the energy in terms of wave number, and that's the expression you will have after dividing the energy expression by hc. Okay, here nu oscillation upon c, you can write it as omega, and omega is known as the classical frequency. Okay, we call omega as classical frequency. Next point, if you are going to put different values of V here, V values can be 0, 1, 2, 3 and so on too. Okay, so we have already observed that too. Now in this case, the values of G which you will get, they will be half omega, 3 by 2 omega, 5 by 2 omega, 7 by 2 omega and so on too. You will keep on putting the value of V here and you will keep on getting the expression or the value of G nu. Okay, now next point. If we are going to talk about the difference, you can take the difference of two consecutive values from this part. 3 by 2 omega minus half omega, that will be omega. 5 by 2 omega minus 3 by 2 omega will be omega. So what it is gonna show, this is gonna show a series of equidistant discrete vibrational levels. Okay, a series of equidistant discrete vibrational levels. So guys, what is the distance you can observe from here? So you can see it's omega. From this series you can answer this question. Next point, if we are going to talk about selection rules guys, so in this case, in the vibrational spectra case, the selection rule is delta V is equal to plus minus 1. What is V here? V is gonna be like the values you have observed for that 0, 1, 2, 3 and so on too. So delta V is equal to plus minus 1. If this is the value, then you can observe the vibrational spectra. Now if any molecule, okay, is going to have the permanent dipole moment, that is another condition, then only it will show the vibrational spectra. The molecule must have the permanent dipole moment, and due to this reason, when we have talked about the homonuclear and the heteronuclear molecules, that which one will exhibit or show this vibrational spectra. Okay, so that's the main reason why one is showing and the other one is not showing the vibrational spectra. The main reason is that molecule should have the permanent dipole moment, only then it can show or it can exhibit the vibrational spectra. Okay, so that's the main point. Next, molecule as an harmonic oscillator, when you will consider the molecule as an harmonic oscillator. Now the point is, in the exam you can have a question as like, when the molecule has been considered as harmonic oscillator or has been considered as anharmonic oscillator. So you have to use the corresponding formulae and selection rules at that time. Here the energy expression will be hc omega e v plus half minus hc omega e xe v plus half whole square plus so on to. Clear? Where omega is the wave number spacing of energy levels. Okay, next, omega e xe here is known as anharmonicity constant. Okay, and its value will always be positive. Next point, if we are going to talk about the energy in terms of wave number for the anharmonic oscillator case, so what you need to do, you just need to divide the energy expression by hc and you will be able to get one thing, like conclusion from here, that is the energy levels of the anharmonic oscillator will not be equidistant this time. As we have observed it earlier, it was equidistant and the distance was omega, but this time it's not the case. Okay, and the selection rule for the anharmonic oscillator case is gonna be delta V is equal to plus minus 1, plus minus 2, plus minus 3 and so on too. Next point, bands which we will observe in the anharmonic oscillator guys, so they are going to be fundamental band, okay, first overtone band and second overtone and hot band. So from which transition you are going to observe the consecutive band? Let's have a look at that. When the transition from V is equal to 0 to V is equal to 1 will take place, you will get the fundamental band. V is equal to 0 to V is equal to 2 will take place, it's gonna be first overtone band. V is equal to 0 to V is equal to 3, second overtone band. V is equal to 0 to V is equal to 4, hot band. Okay, that's how you are going to observe the different bands in the anharmonic oscillator case. Also guys, if we are going to talk about the next point, that is in anharmonic oscillator case, the classical vibrational frequency will decrease when you are increasing the amplitude, or you can say when you are going to increase the value of V. Okay, so corresponding to that, what is going to be the effect on the classical frequency that we have mentioned here? The classical word is mentioned twice, but consider it once only. Clear? Next point, what is the isotope effect on vibrational levels? So basically, if you are considering that the new, like you already know about this oscillation, that is classical frequency expression. The point is omega h, if you are considering this value corresponding to heavier molecule, okay, then you know omega is related to new oscillation upon C. So what will happen? It's like directly you will have omega h is corresponding to heavier molecule and omega is corresponding to lighter molecule. Done. So in that case, you can write it as new oscillation upon new oscillation corresponding to heavier in the numerator and normal corresponding to lighter one in the denominator. That will be equal to root mu upon mu h. As per the dependency of new oscillation on mu, you will have it inversely proportional in this case too. So that's going to be root mu upon mu h. Okay, this is what you are getting, and you can expect the question based on it in the exam that okay, what is the dependency of this omega, okay, on mu, and depending on heavier and the lighter molecule, how you will reach to any conclusion and how you will answer it. So that should be clear to all of you. Clear? Next point, here we can see that the heavier isotope molecule will have the smaller, okay, here you can just get one conclusion, and it is related to frequency. So which is the heavier isotope molecule, that means mu value will be more for that, okay, it will have the small frequency. Clear? So at this point we are getting from the expression we have mentioned above. Also guys, if we are going to talk about, just a second, next point, that is related to molecule as vibrating rotator. Okay, now in this case the vibration and the rotation, both the cases we will consider. So the point is, see, the energy when you are writing it without considering the interaction or without considering the effect of both together, then what you will do, you will just generally add the expressions of energies in terms of wave number you have got for the vibrational and the rotational case. Okay, so that's what we have mentioned here. When we are not considering any type of interaction, it will be G nu plus Fj. This is corresponding to vibrational spectra. Okay, this is corresponding to rotational spectra. Now nu or V, whatever you are writing it, okay, if you are writing it V, you can consider it V here too. Done. Now next point, nu is basically a symbol for frequency we generally use, okay, and V for the vibrational quantum number we are using here. Clear? So yeah, it's V, it's J. Okay, next point, here we have ignored any type of interaction between vibration and rotation of molecule, then we are writing it directly. But when you will consider that interaction between vibration and rotation, then what will happen? I will show you that expression after this one. Here now this is like the sum of energies we have mentioned corresponding to an harmonic oscillator and the rigid rotator. Clear? Those sum of energies have been considered here. Next, in this case what we are going to observe that the rotational constant B, that will be different for different vibrational levels. Okay, after like in this topic we are going to get this particular point that the rotational constant value will be different for different vibrational levels. Now after this, what is going to happen here? It should even be clear to us that what exactly is B. So B is gonna help us to determine or to know about the spacing between the rotational levels, because you know B is rotational constant. Okay, it is like something we have started considering it when we were talking about the rotation. Clear? Pure rotational spectra. So if you will check the previous video, you will have all the points about it as well. Okay, so here we are considering the same B, the rotational constant, but its value will be different for different vibrational levels. This has been observed, okay, within this topic that is related to rotation and vibration both. Clear? Next point, rotational constant in vibrational state, because we are saying that it's gonna have the different value. So what is gonna be the rotational constant in vibrational state? We are representing it with BV, Okay, that is the rotational constant in vibrational state. Okay, and its value is h upon 8 pi square mu c 1 upon r square, and here we have taken a bar. Why? Because we are considering the mean value of 1 upon r square, which is in vibrational state V. Okay, corresponding to the value of V, you have to consider it here. So this is what, this is gonna be the rotational constant in vibrational state. Done? Next point. So here we have mentioned the expression completely, but you can even write the expression of B, that is the rotational constant in vibrational state, like this, which is B minus alpha E, okay, V plus half plus so on to, where see, all the symbols which we have considered earlier, they are having their same meaning, okay, but B is the rotational constant which we are considering for the separation RE, which will be in the minimum level. Okay, so we will consider it. Let's consider rest of the points along with this one right now. Just a second, there are going to be many other points which we will consider. Let's see if it is gonna work. And there are many other points like the Raman Spectra and all. So we'll just try to consider it once again. Yeah, it's here. So guys, let's see whether it is working now or not. Okay, so here what was RE? RE was the separation, okay, at the minimum of potential curve. Clear? So it is at the minimum of potential curve. Now let's talk about rest of the points. Like if you are considering the role or the interaction between rotation and vibration case, so in that case the energy value or the energy expression which you will have, that will be this one, which is omega E V plus half minus omega E x E V plus half whole square. Clear? Also BV J into J plus 1. What is the value of rotational constant in this case? We have already considered that. It will remain same. Next point. What are the selection rules in this case? It is exactly gonna be same which we are having for the separate cases, but here you have to consider it together. Like delta V is equal to plus minus 1, plus minus 2 and so on to, corresponding to harmonic oscillator. We had this one and harmonic oscillator. Done. And delta J is equal to plus minus 1. That's what we are having. Clear? Next point. The branches which you will observe in this case will be the P branch and the R branch. P branch will be corresponding to the selection rule delta J is equal to minus 1. And R branch will be the branch which you will get corresponding to delta J is equal to plus 1. That's important. Next, when we are going to talk about the Raman spectra, guys, in this case there are going to be different lines you will observe. Rayleigh lines, Stokes lines and anti-Stokes lines. Now if we are going to talk about the Stokes lines, what are the Stokes lines? The lines on the low frequency side of exciting line, or you can call it Rayleigh line, okay, is known as Stokes line. Or basically it's not one single line, there are different lines you will have there, so you can call them Stokes lines. Clear? So lines on the low frequency side of exciting or Rayleigh line, they are known as Stokes lines. So that means on a high frequency side, the lines which will exist, They are known as anti-Stokes lines. Clear? Next important point in this case, that's gonna be within the vibrational Raman spectra topic. Clear? If we are going to talk about vibrational Raman spectra, the first point you need to know is the selection rule. That is delta V is equal to plus minus 1. Clear? Next point. In this case, we even observe one more thing, that's gonna be that what is gonna be the intensity of anti-Stokes and Stokes lines and how they are related. So basically the anti-Stokes lines intensity will be less than the Stokes lines intensity. Okay, and another thing is the vibrational Raman shift which you will get in this case will be equal to omega. Okay, and one more thing, wave number of vibrational Raman lines will be V plus minus omega, where V is what? That is the vibrational constant of you can say the wave number. Here V is the wave number corresponding to Rayleigh line, while omega is the vibrational constant of molecule. Clear? So these are the meaning of the symbols. Also, if you will find the ratio of intensity of anti-Stokes line and the Stokes line, you will be able to get it equal to e to the power minus omega hc upon kt. Clear? In case of pure rotational Raman spectra, what will happen, guys? The wave number of rotational Raman lines, that will be equal to V plus minus 4b j plus 3 by 2, which means rotational Raman shift in this case is going to be equal to 6b, 10b, 14b and 18b, like that. So by putting the value of j, you will be able to know about it, that what are going to be the values for rotational Raman shift, and you can get it whether it is equally spaced or not. Also, once you have got to know about the values of let's say that in case of Stokes and in case of anti-Stokes line. Okay, so what will be the distance between two consecutive Stokes lines? Okay, in this case it's gonna be 6b. Clear? Not consecutive Stokes lines. If we are talking about consecutive Stokes lines, so it is 6 and 10, 4, then 10 and 14, 4. But if we will talk about the Rayleigh line and the Stokes line, 6b. The Rayleigh line and the anti-Stokes line, 6b. The distance between first Stokes and first anti-Stokes line, 12b. So that's how you are going to get it. Clear? You can just consider it at the center you will have Rayleigh line, and then both the sides you are going to have the Stokes and anti-Stokes lines. Okay, at the starting I have already mentioned, so they are going to be like this. See, at the low frequency side you will have the Stokes line. Here Stokes, here anti-Stokes, here Rayleigh. Clear? And this shift which you are observing, this shift you are considering corresponding to, see what is V here? V is the wave number of Rayleigh line. So corresponding to Rayleigh line you are going to observe this shift. That means towards the anti-Stokes lines and towards the Stokes lines, same shift will be there initially. So that means 6b, 6b. Okay, that means total shift or distance between first Stokes and first anti-Stokes lines, 12b. Then after that you will have 10b and 10b both sides you will consider. So first Stokes and second Stokes line, 4b. Okay, similarly anti-Stock and anti-Stock consecutive, 4b. So that's how you can consider the difference, and you can even expect a question from this part. And I hope now it will be clear to all of you. Okay, so this was important discussion about all these important points which we have covered right now. Clear? Now guys, I'm going to tell you something about Unacademy Plus subscription. So as you all know, there are going to be so many important courses which are going on Unacademy Plus. So if you want to attend more regular live classes by all the top educators we are having on Unacademy Plus for your upcoming exam preparation, then you can take the Unacademy Plus subscription. Along with that, I will even provide you many important points and the information about it. Clear? And whenever you are going to take the Unacademy Plus subscription, you can use and apply the referral code, that is Anjali Arora, as it is mentioned here. Okay, no space should be there in between and the spelling should be same. So by using and by applying this referral code, you will get the 10% discount in the total Unacademy Plus subscription amount. Also guys, there are going to be different series which are going on. Like right now, this top 50 question series is going on. Okay, this is gonna be the series of spatial classes. So if you want to attend the more regular spatial classes as well, which are for every one of you, you can even attend these sessions. and in the description box of this video I will provide you the link to check all the special classes which we had in this series. They are free special classes, every one of you can check them. Okay, in the description box there will be the link for all those special classes. Also on Unacademy Plus there will be revision courses which you will be able to get soon, clear, and many revision courses have already started. So yeah, if you want to attend the regular live classes of all those courses, okay, you can take the Unacademy Plus subscription, and all these things together will help you a lot to prepare very well for your upcoming exam. Also guys, if you will take the Unacademy Plus subscription right now, then what are the benefits you will get? Okay, let me just tell you that you will be able to attend the many important revision courses, practice courses, and whatever ongoing courses are there for your upcoming exam preparation. Okay, you will be able to attend the live sessions in all those courses. Along with that guys, there are going to be doubt clearing sessions. You will be able to attend the doubt clearing sessions as well, and along with all these benefits, mock tests will be there. Okay, and that's how like you will be able to attend the live classes by all the top educators, so you will get to know about the important strategy and everything with whatever is important for your upcoming exam, and that's how you will be able to do the best possible preparation in the remaining time before the exam. So yeah, even if somebody is going to take the Unacademy Plus subscription right now, and let's say any course has already started and its classes are going on, so you will get the recordings of those sessions, and that's how you will be able to cover up each and every point. Even if you have missed those sessions, you will be able to cover up them. So recordings will be available to you, okay, and you can watch them. Now thank you so much everyone for watching this video till the end. Also, if you are new on this channel, that is Mission at Physics Exam, you can subscribe this channel. Okay, click on the subscribe button below this video. Also guys, click on bell icon after that, which you will get after clicking on subscribe, so that you will be able to get the notifications for the new videos I will provide you. If you like this video and the other videos I have uploaded on this channel, you can even share them with your friends, those who are preparing for the exam. Okay, these videos will be helpful for them too. Okay, and thank you so much everyone for watching this video till the end. Thank you.